TCP is one of the main protocols we use. It is used in most applications, but what makes it so reliable? Under the hood, TCP includes packet error checking, data loss prevention, flow control, and congestion avoidance. To start a TCP connection, the initiator, in this case our client, sends a synchronized packet, also known as Syn packet, which tells class wants to make a connection. The server responds back with a Syn Ack packet, which tells the server is ready to make a connection as well. And finally, the client sends an Ack packet. It indicates the TCP connection is established. The back and forth of these packets is called a three-way handshake, and it establishes a TCP connection between the nodes. And once the connection is set up, the application data can begin to flow now. One thing to note is, during a three-way handshake, both nodes share their initial sequence and acknowledgement numbers. These numbers are crucial, so let's see how it is utilized in a TCP connection. Let's assume the client sends a packet with a sequence number of 1 with a TCP segment length of 1436. The receiver takes a sequence number, adds the length of the TCP segment, and calculates a new acknowledgement number. The server responds with an acknowledgement, which tells the sender that the receiver is expecting a segment with a sequence number of 1437. When the client sees this new ACK number, it knows the previous 1436 bytes of data was received by the server successfully. Again, the client sends a new packet with a sequence number of 1437, and this time with a TCP segment length of 1400. The server responds with an ACK value of 2837, which tells the client the next segment should have a sequence number of 2837. This process is repeated back and forth until the end of the TCP session. And this back and forth of sequence and acknowledgement guarantees two major things: data loss prevention and in-order delivery of the packets. Let's assume a packet with a sequence number of 2837 gets lost. The client sends yet another packet, but the receiver can detect the gap in the sequence number, and it knows exactly how many bytes of data is lost, and it can request for retransmission using an automatic repeat request packet or ARP packet. Similarly, if a sender doesn't get an acknowledgement for any of the sent packet, it will resend the unacknowledged packet after the packet exceeds retransmission timeout value, aka RTO value, which is dynamically adjusted based on various factors. TCP also ensures in-order delivery as well. By looking at the sequence number, the receiver knows the correct order of the packets, and even if the packets arrive out of order, the receiver holds onto those packets in its buffer memory until it receives the missing pieces, and uses the sequence number to reorder them for proper reconstruction of the data stream. If you learned something new, consider subscribing to the channel. Leave a like and comment. Your engagements help motivate me to keep creating content.